Alright, this is a lesson for day 131. We're going to be talking about the remaining trig ratios and converting from degrees to radians. So last time we talked about SOHCAHTOA, which was a review from geometry. So there's a few more trig ratios that are the inverse of them. So let's just start with SOHCAHTOA. Turn to your neighbors, tell them what SOHCAHTOA means and what does each one represent? Okay. Okay, so I wanted to show you a few more of them. So here are a few more. So you see how sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, right? We know that. But now look at these, okay? This one's called cosecant. It's hypotenuse over opposite. Secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. When you compare these two together, look at the top one with the bottom one. What do you notice? And tell your neighbors what you notice. Okay, ready? Go.
Flipped. They're just like flipped.
What do y'all notice?
It's flipped.
It's flipped. What's that called when the fraction is flipped?
Reciprocal.
Reciprocal. Okay, good. Okay. So if you want to write these bottom three down, you can. Why don't you take a moment to do that? I'll pause the video here. Okay, so we could find the all 6 of these trig ratios on any particular angle on a right triangle. So numbers 1, 2, and 3, you might say, oh, this could be hard. It's not going to be too difficult if you look at that each side is its own, each trig ratio will have its own fraction, okay? So we know what SOHCAHTOA is, and then we could easily find what the cosecant, secant, and cotangent are. So I'm going to do number 1, okay? So we got number 1, I got this angle theta. The angle theta, we don't know what it's equal to, but we can figure it out with any of the trig ratios we want, okay? And we got some numbers here. We got 5, 12, and 13 here. So first thing I'm going to do is start with sine. So I know sine is opposite over hypotenuse. So sine of theta is going to be equal to 5 over 13. Then I could do cosine of theta is going to be adjacent over hypotenuse, which is going to be 12 over 13. Okay. The next one is tangent, which is going to be opposite over adjacent, which is going to be 5 over 12. Okay? And these are the ones we know that are really easy, right? So to do the next ones, they're pretty easy, right? Cosecant. Isn't cosecant just the flip fraction of sine? Remember that? So we could just say cosecant of theta is going to be 13 over 5. Secant of theta is going to be the flip fraction of 12 over 13, and then, or 13 over 12, and then cotangent of theta is going to be 12 over 5. And that's it. Okay? And that's how you do number 1. Very quickly and easily. Right? So this is the first part of the lesson. We're going to identify all the ratios, and we're going to go into the unit circle next. Okay, any questions on number 1? Okay, cool. So let's have 4 start today. I'm going to switch it up. 4s, you're going to start today. If you don't have a 4, let's just go to the next number 3 to discuss how did I figure out all the trig ratios on number 1. Ready, set, and go. Okay, so what I'd like you to do, let's have you practice with your groups. I'll give you 3 minutes. I'd like you to do numbers 2 and 3, 2 and 3 by yourselves with your groups, okay? So you can math chat, help each other out. 2 and 3, and then I'll show you the answers, okay? So ready, set, and go. So for number 2, here are your ratios. Let's all look at number 2. Sine of theta should be 3/5. Cosine of theta 4/5. Tangent of theta is 3/4. Cosecant of theta is 5/3. Secant of theta is 5/4, and cotangent of theta is 4/3. Any questions on number 2? Raise your hand if you got it right. Okay, give someone a high five if you got it right. Are you good? Did you get it right? Number 3. Sine of theta is going to be rad 2 over 2. Cosine of theta is rad 2 over 2. Tangent of theta is 1. Let's just start with these. Are we good with these first three for SOHCAHTOA?
Yes.
Okay. Because, right, we're going to, anytime you divide by the hypotenuse is 1. Now, cosecant, it's a little bit more crazy. I did the cosecant problem down here as a side problem. Cosecant of theta, it's like saying hypotenuse divided by the opposite, right? But the opposite is rad 2 over 2, so I'm actually going to be multiplying by the reciprocal, so it's going to be 1 times 2 over rad 2, which is 2 over rad 2. Then you would have to rationalize the denominator, and when you do that, you get rad 2. Secant of theta is the same, rad 2, and then cotangent is the same. It's still 1 because you still have the same thing divided by itself. Okay? So tangent of 45 is always equal to 1. It's a nice number. And that's it. That's the first part, okay? The second part we're going to talk about is now going to be the... we're going to talk about degrees and radians. So I'm going to show you a little video here in the classroom. Sorry I can't show you this in the video. Okay, so now that we know that that it takes about 6.28 radians to get around a circle, that's 360 degrees, right? Would you all agree with that? Okay, good. So we're going to need to know that radians and degrees mean the same thing. They're just different measures. Just like $1.5, would you all agree that $1.50 is $1.50? Right? Would you also agree that I could say I have $1.50? Isn't that the same measurement? Does that make sense? Okay, so we're going to say degrees and radians are the same thing. Okay? So, oh, that's the wrong one. That's the wrong lesson. Sorry about that. Here we go. My bad. Here we go. Let me go to the right screen now. That was what we were working on. So now we're going to convert to radians on number 1 here and then degrees on number 2. Now it looks scarier than it is, so it's really not. So 30 degrees, right? Does 30 degrees go around the whole circle? How many radians about to get around the whole circle? 6.28 radians, right? How many degrees to get around the whole circle? 360. So 30 is really small compared to 360, right? So check this out. In order to convert this to radians, you take the original degrees, 30 degrees, times our fraction of pi over 180, okay? And then I make both of them a fraction. Then I ask myself, what can I simplify before I multiply?
30 and 1.
Good. What goes in the book? 30 divided by 30 is? 1. Good. And then 180 divided by 30 is? 6, right? So then you would multiply across. 1 times pi is pi. And 1 times 6 is 6. So our answer is going to be pi over 6 radians. That's for number 1. Okay? So 30 degrees is the same thing as pi over 6 radians. Okay? That's number 1. Number 2, what if I start with radians? Okay? How many pi radians to get around the whole circle? How many pi radians to get around the whole circle? No, that's how many radians. 2 times pi. So how many pi radians? No. How many pi radians? 2 pi radians. Okay? Right? Okay, good. So 1 pi radian would be halfway around the circle. How many degrees do you predict this to be? 6.28. Don't just repeat what I've taught you earlier. Think a little right now. If 1 revolution around the circle is 360 degrees, and that means 2 pi r around the whole circle, what would 1 pi r around the circle be?
90.
Yeah, halfway around the circle, right? Does that make sense? Okay, so we start with pi radians. We multiply times our 180 divided by pi. And then I make both of these a fraction if I have to. Can I simplify anything before I multiply? No. What's pi divided by pi? 1. Not none. 1. Okay? And then we got 1 times 180 is 180 degrees. And 1 times 1 is 1. So your answer is 180. Okay? And I think people are getting confused with this. So remember earlier I said, I just want to clear up something really quick. How many radians across the whole circle again? 6.28 radians, right? And how did this 6.28 come from? Where did it come from? 2 times what? Doesn't this come from 2 times pi times r? Would you all agree with this? So when I say 6.28 radians, it's really like me saying 2 times pi times r, right? Okay? So we use pi because pi is an ugly number. It's 3.14 and it keeps going on forever, right? So we just put that all together as pi. Okay? Numbers 1 and 2. So let's go to number 3. Our 3's in our group. 3's are going to explain to the rest of the group. How do we do numbers 1 and 2 here about converting between radians and degrees? Ready, set, and go. Do a few more. We'll go through this quickly. Number 3 and 4 we'll do together. Here we go. So number 3, it says, convert number 3 to radians. We have 150 degrees. Okay? So we're all doing this, right? All of us? Okay, so we start with 150. What are we going to multiply 150 with to convert it to radians?
Pi over 180.
Okay, pi over 180, right? And then I'm going to make 150 a fraction. Turn to your neighbors and tell them how you could simplify this before even multiplying.
I'm going to divide both sides. 3.
Think bigger, not 3.
Oh, no.
Okay, what goes into both 150 and 180? 30, good. So 150 divided by 30 is 5. And 180 divided by 30 is 6. I think Seth got that first, okay? So want to make sure the video got that. Seth got that first. Want to make sure he's happy. Okay, so we multiply across. 5 times pi is 5 pi over 1 times 6 is 6, right? So it's 5 pi over 6 is your answer, okay? Because we know 1 pi is 180, right? So 5 pi over 6 is 5/6 of the way there. Does that make sense?
Why are you not timesing 5?
Okay, so this is one way to write it. You could also write it as 5/6 pi. Okay? What?
No, I don't need multiply the 5 times pi. I do 5 times 3.
Because we want to leave that alone. Because pi is such a large irrational number. It goes 3.14 and it goes forever.
Oh, okay.
So we leave pi in its own pi. We just assume all that big, long, unending number just becomes pi. Yep.
During the test, is that going to be the answer?
Yep. Yep, that's the answer. 5 pi over 6 or 5/6 pi. So how many pi's to get around the whole circle? 2 pi's, right? So 1 pi is how many ways around the circle? Good. So when I say 5/6 of a pi, that means you're only going 5/6 to the half. Does that make sense? You're going 5/6 of the way, which is 150 degrees. Does that make sense so far? Cool. So 3 pi halves. Predict how many degrees would that be? Is it bigger than a pi? Less than a pi?
I think that's going to be 3.
So how far around the circle will this go? Just how many pi's to get halfway? No. Okay, start from the beginning. How many pi's to get around the whole thing?
3.
Okay, listen. You kids are just shouting the answer. Listen. How many pi's to get around the whole circle?
2.
Good. How many pi's to get around half a circle? 1. Good. So 3/2 pi is how many ways? How far around the circle?
More than 1.
More than 1 whole way around the circle?
It's like 1. Wait,
Talk to your group about it. Ready, set, go. How far around is 3/2? Okay, so how far around is 3/2? Is it a full way around?
Yes.
Wow, you kids are not thinking about it. Let's talk about our fractions. 1 pi is how far around the circle?
Half.
1/2. 2 pi is
Full.
full one way. So 3/2. Isn't 3/2 between 1 and 2?
1.5.
So how far around the circle? Is it 1.5 times around the circle? No, that's wrong still.
Then it has
What is it?
3/4.
Yay! Let's give it up for Juliana. 3/4 of the way. Thank you. Right, so let's draw a picture because some people are still not getting it. Ready? Okay, ready? Eyes up here. How many, if you got 2 pi, how far on the circle are you going?
You're gonna go
1. Okay, if you got 1 pi, how far do you go around?
You go half.
Half, right?
Yeah.
Good. If you got 3 halves, how far around do you go?
Then you're gonna go 3/4 around.
There you go. Thank you. Does that make sense, everyone? So how many degrees is that then?
What about 5 halves?
How many degrees is 3/4 of the way around? 270. Okay, let's check our work now. Okay, 3 pi over 2. I know it's confusing, but once you get the concept, it's easier. So 3 pi over 2, let's do this. We're going to convert it to degrees. So start with 3 pi over 2. What am I multiplying 3 pi over 2 with?
180 over 5.
180 over pi. Good. So before, what can I cancel out before I find my final answer? Pi becomes pi divided by pi becomes 1, right? What else can I cancel out? 2 divided by 2 is 1, and 180 divided by 2 is 90. So what's 3 times 90, everyone? 270, that's right. 270 is correct. That's your answer. Excellent. Okay, let's do 2 more. You're going to... Okay, number 5 and 6 by yourselves. You can even check with your neighbors if you need to. Ready, set, go. Okay, here are your answers. This one is going to be pi over 4. That's correct, right? Think about it. 45 degrees around. How many pi's to get halfway? How many pi's? 1, okay? So if I only want to go 45 degrees, it's only here. So how far is that? Well, half of it is pi over 2, so half of a half is pi over 4. Does that make sense? Okay, next one, 7 pi over 4. The answer is? What is it? 7 over 4 is close to what number? 1, 2. The answer, 270. Any other answers? 315, 310. Okay, here's your answer. 315 is the correct answer. Okay, that's it. So we're gonna end the lesson there.